All right, Robert, why don't we get going? You ready?
Ready when you are, yes.
All right, great. Good afternoon. My name is Pedro Pierce. I'm from Eduporium, and welcome to our continuation of our spring webinar series, which has been on a focus on innovative and vetted kind of educational STEM products we feel that would be great in a classroom. And with me today, I have Robert Grover from databot. He is the CEO, and he'll be doing the majority of the presentation today. Just a couple quick, I wanted to kind of just do a quick overview who Eduporium is. But a reminder today, we're going to keep it to 45 minutes. We would encourage people to ask questions. There's no question that is not a good question. So please ask questions. I think we all learn from that. And actually, it's a great way for even myself to kind of keep learning on it. You feel free to use the chat, and someone on the Eduporium team will connect, and I'll jump in and ask a question live as we move through it. We are taping today's seminar just so that people can come back later on and look at it. And then also at the end, we will send out in a day or two a copy of the presentation, any resources that Robert uses, and anything else that might be something that could be good to kind of gain a better understanding of the solution. And lastly, probably most importantly, Robert has agreed to provide to one of the attendees today the databot 2.0 single kit, and we'll talk more about how that will go at the end here. So once again, welcome. We know you're busy and it's a tough time, so we wanted to kind of get right into it. What I wanted to just take a second is explain who Eduporium is. And I guess the way I would explain it is our focus is just on education, and our focus is also on STEM educational technology in the classroom. We focus exclusively on that. We have a variety of different solutions in this space, from coding robots to drones to virtual reality and tools like databot, which are great new tools that we're excited to have. The big advantage we have is we'll work with you. We work with customers and understand exactly how they've deployed in a classroom or an after-school organization, and can properly advise you as you go through the process and stuff like that, or if you're putting together a grant. We do provide an educational discount where possible. Not always can we do it, but where possible, we can do that. We work across the United States. We are based here in Newton, Massachusetts. In addition, we are a certified minority business enterprise, which is a key component of our company. So with that, I'm going to hand it back to Robert, and I look forward to kind of learning more about databot 2.0. Thank you.
Sharing my screen. Hopefully everybody can hear me. Just a quick test. Paolo, can you raise your hand?
Yep.
Being heard? Okay, great.
I can hear you.
All right, we should see a presentation slide up now that says databot 2.0. Is everybody seeing that okay?
Not yet. For some reason, it could be maybe my screen, Robert. Let me just see something. Yeah, I see it.
We got it? Okay.
Yeah, I got it.
Super. All right, well, welcome everybody to databot 2.0, a data and visualization tool. So databot 2.0 is quite new on the market. So for those of you who are attending, you may not have even seen this yet. We released version 1 a few years ago. It's been really successful. And in February, we started shipping this new version, which is smaller, more powerful, and has some amazing features, which we're going to show you today. So in today's webinar, we're going to cover a number of different things. We're going to look at the kit contents, how it works. We're going to look at the different sensor values you have access to. We're also going to take a look at some of the physical computing attributes of it, because it can be used in STEM programs. So if you've got existing robotics programs, for example, you may want to integrate this to it. And there are lots of ways to do that as well. I'm going to give you some specific activity examples so that you can see how it's used in the classroom. I've got 2 or 3 experiments that are very simple that I think will give you a really quick understanding of how you can apply it to different sciences and different activities. We're also going to look at the app. So there's a free app called Vizeey that comes with the product. And Vizeey is something that you can actually use in the classroom right away. We've got a free lesson plan that we're going to supply to everybody who attends today that will allow you to use the app and the sensors that are on board a smart device to do a really fun activity called the Ninja Walk, which I'll tell you a little bit more about in this presentation. But at the end of this thing, you're going to end up with actually a curriculum and an app that you can walk away with and use this week. And it's a lot of fun. And it's a good introduction to how you can start getting data integrated with your class activities. The other things that we're going to look at, we'll take a look at the NGSS fourth practice. We're going to look at some other software that you can use with databot. It's extremely flexible. You can program it. You can use it out of the box with the app. You can do advanced computing activities with it, like machine learning. It's a pretty remarkable product. So I'm excited to share it with you today. So a little bit about our company. My name again is Robert Grover. I'm the CEO and founder of the company. My co-founder, Heidi Grover, is also my wife. We've both been working in STEM education for over 30 years with several other companies. Got a lot of experience developing, designing, producing STEM products. We've taught STEM classes. We've worked with thousands of kids over the years. And I think we've got a great understanding of what really works with kids because we've been there. So databot is our newest product. As I said, we released the first version a few years ago, and this new version is even better. The neat thing about databot and its versatility are all the different things you can do with it. So we have 4 major topics that we focus on. And one of those is STEM or STEAM. And as a tool, you can use it for teaching all of the core sciences. You can do design engineering challenges. There are a lot of applied math things you can do because it's pure data and math in a lot of ways. The sensors that are on board allow you to teach all of the different core sciences like physical sciences, chemistry, earth science, life science, and then of course environmental activities. So we have a number of activities that are applicable to climate change, environmental awareness programs. We also have data science, data literacy, and critical thinking applications to this product because again, it's all about data, learning how to read and analyze information that's being presented to you. And finally, I had mentioned that some of the advanced things you can do with it. It's got applications in both AI as well as machine learning. So starting AI as young as 4th grade, and then of course, clearing the university level for doing machine learning. Anyway, that's a little bit about databot. We're based here in Boise, Idaho. So we are a US company, and we've been working with kids for over 30 years and would love to share this new tool with you that we think is just fantastic because of all the things it does. Now, the kit that we're giving away and the kit that is for sale is databot version 2.0. This is what's included in a typical kit. I'll hold up the case here so you can kind of see the scale and size. You can see in the video monitor, looks like so. We sell these in twin packs, individual kits, and then also a class pack of 10. So 10 is your beginning recommended amount for the classroom. You can have teams of kids using them, 2 or 3 kids per databot, and the activities are very conducive to teamwork. So what comes in the kit is, of course, a databot itself. It's very small, which I'm going to hold one up here to the camera. You can see in my hand the scale. It's 1.67 inches on a side, and it's about 3/4 of an inch tall. So fits in the palm of your hand, but it has all kinds of crazy things built into that little package that you can do with it. Also included is a waterproof temperature probe. I'll hold that up for you as well. It plugs into the ports on the databot, and that is something that you can use for experiments where you might be dropping the temperature probe into a beaker or stream. The databot itself is not waterproof. I want to emphasize that. You don't want to submerge the bot itself, but the temperature probes are waterproof. And then also included is a lanyard. So that's what that little blue thing there is. I'm going to hold it up here for you so you can see. The lanyard is easily looped through the side of the databot, easily removed or put on. And this is an example of an activity that I just did this morning. Actually, I've got a screenshot of this that I'll show you in a few minutes, but it's actually looking at the acceleration data on a databot being used as a pendulum. Last but not least, you get a little charging and coding cable. So the databot has an onboard battery that charges in about an hour and runs for 5 to 6 hours. And there are also ways that you can extend that run life by plugging it in or giving it extended battery banks, so that if you wanted to run a really long-term experiment, you have the ability to do that. Anyway, those are
Robert, just a quick question. And I know you kind of mentioned, I just want to reiterate. So what devices would you have to have besides the databot to run this?
So databot is a wireless device that can communicate by Bluetooth to smart devices. So that includes anything that runs iOS, so iPads, iPhones, also Android devices, Android tablets, Android phones, and then finally Chromebooks. So the app runs on all of those devices. If you're using a PC, you would be using, potentially Excel. You can stream live data right into Excel and other software programs. The Mac has other options as well. If you think about databot as a tool for collecting and delivering data, any software that you may be already using that uses data to analyze or display it can be used.
Perfect. Thank you.
So here's a shot of all of the sensors that are on board. What is this thing? Again, it is a low cost, very friendly little product that is really designed for interacting with your environment around you with sensors. So to that end, it's got all of these sensors that are built into the device. So with one device, you can look at things like the ultraviolet index. You can check your altitude. You can look at air pressure. You can take readings of air quality, including volatile organic compounds or carbon dioxide levels. You can do tests of what are the light levels in the room. You can look at magnetic fields. You can look at sound levels. So this one little device, very versatile for all of the different sciences. And that's really the goal for our company, is to make this device something that literally should be in every classroom. Kids should be able to just grab one, connect to it, and start conducting experiments. You're trying to facilitate explorations with a device like this. So natural curiosity in kids as you conduct, formal experimentation is something that you really want to fuel. So you want them to start developing their own experiments and making it easy to do that. And databot does that because, as I'll show you in a few minutes, it's super simple to connect to, and you literally can be up and running in 60 seconds collecting data for any experiment that might come to mind. So this is a layout of the databot. This is a top view, and this particular slide I'm using to identify the different physical characteristics of it. So you've got different ports on the databot. On the left-hand side, you'll notice we've got these micro USB ports. Again, those are for the temperature probe, which I'm holding up here. So you can have up to 2 probes reading simultaneously. If you have an experiment that you need to be tracking 2 different temperatures, you can do that with databot. The kit includes just 1 probe. Additional probes are for sale for only $9.99. So it's very inexpensive to add on the second one if you're going to be doing chemistry or environmental activities where you want to be monitoring 2 temperatures. The switch is on the left-hand side there, and I'll hold up again the databot to show you. The case is smooth and flush all the way around. There are no switches or anything protruding from the case to snag or get caught on anything. This allows you to put it into a lot of different environments without, fear of, a switch being snagged or pulled off or things like that. So anyway, you basically press down on the case itself, and it's going to activate the databot, turn it on, and it'll start looking for your software, which I'll show you in a moment. On the back side, that's another micro USB port, which is for charging it. So you plug it into any 5-volt USB source, whether it be your computer or a phone charger. Anything will charge it. And as I mentioned, in about an hour, full charge, and it'll ready for 4 to 6 hours of runtime, depending on how many things you're doing with it. Physical computing attributes. These 3 circles that I've got over the board highlight the LEDs that are programmable. So they're RGB LEDs, which means they're completely color programmable. You can have them light up in all kinds of different colors and create light and sound shows using those LEDs and the tone generator that's here. We've had activities done by kids that, for example, they program it to do songs. I had one student do Billy Joel and the Piano Man, which was hilarious to hear the little databot playing the Piano Man, but it had lights flashing and things like that. So lots of great physical activities you can do with it for getting kids involved in physical computing, which I've always been a big proponent of robotics and having kids doing physical building and learning how to make things move. This is another piece of that whole thing where you can actually focus on just getting kids interacting with physical computing exercises without having to worry about all those components to start with. There's a huge value to the building and the engineering design piece of robotics, but there's also certain elegance to be able to just focus on the physical computing attributes when you want kids to focus on the code. And databot does that. So on the other ports here on the right-hand side, we've got 2 expansion ports that allow you to add on additional sensors from other systems. And that's also the communication ports if you want to plug it into various robotic devices. So for example, we've done integrations with Fisher Technic, with Lego, with Sphero. Any of the major systems that are out there probably have an ability to integrate with this because these are very common communication protocols. So that's a quick look at the physical design of databot 2.0. And then this is a layout of the different sensors. And I've already mentioned some of them. Since we've got limited time, I'll go through these fairly quickly, but I'm going to show you where they live on the board. So for example, we've talked about the temperature probes. Those plug in over here on the left. The air pressure and altimeter, that is one sensor that's built in here. You'll notice it's labeled. If you can see that on the board, it says air. And that's one of the things that we've got pretty consistent feedback from educators. They love the fact that this case is transparent and that you can see it and that the kids can actually look at the sensors and identify, okay, that's where that sensor is. And that's where that data is coming from. In our initial sensor starter activities, we actually explain a little bit about how each of these sensors works, where they live on the board, what the units are that they are being, that they're reading out. So kids can understand the technology behind it as well as the data that it's delivering. So it's a great learning experience just all around. So your UV index, you've got a UV sensor right here. You'll notice that there's a penetration in the case. There's a hole there. And that's because, and this is a great teaching moment also, polycarbonate, which is what this case is made of, has natural tendencies for blocking ultraviolet wavelengths. So we've got a hole there that actually allows that wavelength to pass through completely. And when I do activities with that particular sensor with kids, you take it out in the sunlight and you can move this around and the hole will actually project a little sight onto the board. It'll show a little circular shadow. And I tell the kids, hey, that's your shadow sight. You got to get that pinned right on the ultraviolet sensor and you'll get a very pure UV index reading. And then you can talk about ultraviolet light and how it can be detrimental if you're exposed too much. You can talk about, the different wavelengths in sunlight. And it's a great teaching piece right there. So humidity also right there next to the UV, you'll notice that it also has a penetration. So there's lots of airflow through the case to allow for readings of things like carbon dioxide or humidity, things like that. Okay, over here on the right-hand side, the sound sensor, there's a microphone. You see a little hole right there. Microphone is actually mounted on the back side of the board, but there's a hole that penetrates that allows the sound to access that sensor. And you use that for sound intensity. So teaching kids about, decibel levels. And you can see the sound level in your classroom. You can take it out and take measurements of sound intensity in the parking lot or near the road. And it's a great environmental piece that you should add into things when you're teaching kids about environment. So it's not just air quality or things like that. It's also about, light quality and sound quality. The accelerometer, gyroscope, and magnetometer are all in one module here in the middle. Those sensors are used for a lot of the physics applications. And you'll notice it's centered right smack dab in the center so that you can use it for things like spinning it in a top and all kinds of fun things. So a lot of physics activities that you can do with that particular sensor. Your air quality is over here, and that's where it reads the carbon dioxide and volatile organic compound levels. One of the activities I'll show you actually relates to volatile organic compounds, which is a really good activity for getting kids introduced to potentially harmful pollutants that are in the air around them and in their environment at the home or wherever they might be. And then our final one is, let's see, I've got 2 more actually. One here, this is a combined sensor that is ambient light, color, gesture, and proximity. And gesture, for example, is used in the coding. So for example, you can program your databot to go and turn on blue and squeak if you go and wave right to it. And it might turn red and moan if you go left. So things like that, again, for physical computing, that's why you have a gesture sensor in there. And then last but not least, we have a long range proximity sensor. This one's 2.5 meters, so you can use it. It bounces a signal off of a material, and you can use that for calculating speed or distance or all kinds of things. So that's a quick overview of all the sensors that are on board. How do we use them? We use them with an app called Vizeey. Okay, so when you turn on databot in its default mode, and I say default because it's got different modes that you can turn it on in. But if you turn it on facing up like so, and you should be able to see on mine, there's a little pulsing blue light. And that means it's looking for a connection. And you basically access it through Vizeey. You tap on the icon, it'll connect to databot, and then you're immediately able to start reading the data. And these are some screen captures from Vizeey. So you can see that you've got kind of an icon-based screen here. We tap on any one of those icons and it'll go right into the experiment, and then you start reading and recording. And it's very easy to get the data recorded and out of the device, or you can just use the device for real-time discussion and analysis. So this particular one that's being displayed here actually shows 3 different values. You're looking at carbon dioxide, a temperature reading, and a humidity reading. Very easy again to use. I demonstrated this to a science coordinator yesterday, and he was frankly amazed that you could literally install the app and be connected and reading data in 60 seconds, which is entirely possible with this device. So that's Vizeey, and we're going to have you actually install and test Vizeey today in this webinar, so you'll get a little taste of it for yourself and be able to use it in your classroom. This is an example of a simple activity. So the little screens there are actually out of Vizeey. You can see the light intensity being displayed. And the activity is very simple, asking the kids, okay, light has different characteristics. What are some of those? Well, one of those is that light becomes becomes fainter, less strong as you go away from the light source, right? So this is a very simple experiment where you can put databot close to a light bulb. So at 20 centimeters, what is the light reading? What is it at 40? What is it, 60, 80, 100? And you can see that, you know, the difference is very clear as you study the data. So that's a good example of a very simple activity. This is from one of our sensor starters, which begins actually introducing the concept of the sensor and how do we measure light? You know, we don't use a ruler to measure light. We use something called lux, which will actually be, you know, a unit of measurement similar to an inch, only it's measuring light. And so, for example, here we're measuring 838 lux when we're a long ways away, and when it's very close, 10,000 lux. So you can get an idea of what, you know, what data actually translates to in terms of brightness. This is one that I did just this morning. This is also a Vizeey screen. This one's pretty interesting because it actually shows you, you know, the dissipation of energy on a pendulum. So what I did is I started reading the data, I lifted the pendulum up and I let it go. And you can see that, you know, due to friction and friction with the air and the actual friction with, you know, my fingers and the line, you can see that the energy is dissipating, very regular oscillations. And that allows kids to actually see that in real time. So another great example of physically interacting with data. This is another one. This is volatile organic compounds, which I mentioned. So putting databot inside a container, you can see them trapped in there with a little beaker of vinegar. And vinegar is a natural emitter of VOCs. Okay, so volatile organic compounds are hydrocarbons that expire or evaporate at room temperature. So when you can smell gasoline, when you go out into your garage, for example, those are VOCs. Cleaning compounds, vinegar, all these different things will be off-gassing. New furniture, when you buy it, if it's got you know, some artificial materials in it, will be off-gassing. So these are some of the things that people are becoming more aware of. Even the varnish on your desk may be off-gassing if it's fairly fresh, or paints. So one of the things we need to teach kids is you need to be aware of, different things that may actually be putting harmful vapors into the air around you. And with databot, you can actually test that. One of our activities is we have a treasure hunt, and we turn the kids loose and they try to find the source of dangerous volatile organic compounds. We actually leave a container of like paint thinner open. And as you get closer to it, you'll see the levels go up. And then this, whoops, wrong direction. This is another example of using the VOCs. Using that same setup, you can actually put baking soda into the same environment. So you remove the vinegar, you put the baking soda in, and you seal it back up. And then databot is actually going to read as the baking soda interacts with the volatile organic compounds. It's essentially scrubbing, those from the air. So that's another great experiment where you can actually show chemical reactions actually taking place. And visualizing the data is very simple. Something like this, you can see it's very, very consistent, and it's got a very clear rate of what's going on here as that baking soda is interacting with the VOCs in the environment. So lots of applications. We just looked at, just a couple sensors there, but you have 16 sensors to work with across a wide variety of areas. So now what we're going to do, we're going to take a moment to actually test this out yourself. I'm going to have you all, hopefully you have access to a smart device. It can be an iOS, so if you've got an iPad or an iPhone, or if you've got an Android device, go to your app or Play Store and look for Vizeey. It's spelled Vizeey. And we named it Vizeey after visualize, so visualizing data. And I'll give you a moment to look for that and install it. I've got a little video that we share with people. You literally can install this and be up and running in 60 seconds. So hopefully it won't take you very long. The only thing that it depends on really is your bandwidth. So hopefully it'll download quickly. Once you download it and run it, it'll come up with a blank screen, and there should be a plus sign on there. The screen I've got up here already is populated with some experiments, but when you first download Vizeey, it'll be blank, and you should see a plus sign either on the bottom or the top, depending on which platform you're using. If you tap on that, one of the options is going to be add experiments from QR code. And this is another one of the simple things about this app and this particular approach to using, databot. It's so simple to scan a QR code off of a lesson plan, and it'll bring in the experiments that you need to support that. So there's no configuration. There's not a lot of fiddling around. You get the lesson plan out, you scan it. The experiments are going to be right there for the kids to go through. And we'll give you one more minute. If you've managed to scan it and get the collection in, at the bottom of the collection, it's going to say, do you want to save this collection? You want to say yes. And what you've loaded in is a collection called Ninja Physics Smart. So this is the smartphone version. We have a databot version also that allows you to do these same experiments connecting to databot. But this is a great way for everybody to be able to try the app and understand some of the things that we're doing, interacting with data just at home. So if you've managed to get it installed, I want you to select the icon that says 3D Basics. And it's going to bring up a screen similar to the one on the right. There's a little icon at the top. You'll notice that on my screen capture here, it's showing a pause, but if you haven't started it yet, it'll show a little right pointing arrow, which is like a play icon. Tap on that, and you should have live data coming into your phone. Now your phone, if you hold it flat like so, you have the Z-axis, which goes through this way, because your accelerometer is a sensor that's laying flat in your phone, right? So just like in databot, the Z-axis goes right through the center, up and down. So if you can hold that perfectly level, you're going to be reading acceleration due to gravity, which should be around 9.81 meters per second squared. And the challenge that we have with kids is, okay, now hold it as steady as you can. Can you get 9.8 meters per second squared on the Z-axis? Okay, they get as close as they can. It's literally impossible to do it perfectly because there's there's always motion and there's always movement going on, and the sensors are very sensitive. So anyway, once you take a look at the Z, you can rotate it. So you're holding it upright. And now you're going to be looking at gravity on the y-axis. And then if you turn it horizontally, it'll be on the x-axis. If you turn it, flip it the other direction, you'll notice also that it changes from positive to negative. So now you're getting a feel for three-dimensional coordinates using Vizeey and that particular sensor, and you're actually reading the force of gravity. Now, we won't go through the activity set in this webinar because we don't have enough time, but we're going to send a PDF that Eduporium is going to be able to send out to all of the participants that actually goes through all of the experiments that are loaded up in that collection. And it's a great classroom activity. It'll walk kids through, first of all, this one where you're experimenting with just the 3D coordinates and learning, where's the force of gravity being applied. And then there's timed challenges, which is fun for the kids. So, right, a steady hand does what I was just explaining to you. They're timed for 10 seconds. And the challenge, of course, is can you hold it as steady as possible for 10 seconds and come out as close as possible to 9.8 meters per second squared. By the time kids finish this set of activities, they've got a really good understanding of acceleration due to gravity. They'll never forget 9.8 meters per second squared. And they also understand a little bit more about just the nature of acceleration. So for example, Smooth Walker has them moving and holding the phone again in front of them and trying to get as close to zero acceleration as possible on the y-axis. And this teaches them that, hey, I can be moving, but have zero acceleration. Yeah, great hands-on introduction to some physics concepts and something that you'll be able to do in your classroom. As I said, we'll send that class plan out to everybody so that you can enjoy it.
Yeah, Robert, I think from an Eduporium perspective, I know we all loved when you did that demo, we all did it. And it was a great way to kind of, conceptualize and actually see in reality, in your hand, some of the physics concepts. So it was cool to see that. So, hey, one quick question, Robert. Someone asked, and I think you're going to cover it, but is there a way to incorporate databot into a tele drone or any type of drones? I think you have that, correct, later on?
Yeah, exactly. We've got a picture of that coming up here shortly.
Great. All right. Thank you. I thought that. Thank you.
Yep, I'll show it to you here in just a moment, because what we've talked about so far is just the different ways to access the sensors using Vizeey and apply it as a science tool. And it's super easy to use, as I've shown you. And the other activities that you can do with it go beyond that. So the things like coding or doing experiments with drones, that becomes more accessible on the STEM side, which we'll take a look at here in just a second. Last thing I wanted to wrap up, the sensor science side with is just a little bit about the NGSS. So the NGSS, of course, has 3 dimensions to it. One of those is the practices, what kids and scientists actually do when they're doing science. And the 4th practice is one that's very important. It's all about being able to analyze and interpret data. So obviously, anytime you're using databot and Vizeey together, you're encouraging the use of that practice and developing that skill in students. And I think the younger we can start kids interacting with data, like we've just done with Ninja Physics, or exploring VOCs or acceleration, all of those things, they start to turn this invisible world of forces and scientific data that surround us into actual, quantifiable numbers and data, and kids start to analyze and interpret that. And they start to understand the physical world around them a lot better. So it's important. I know everybody's always challenged to meet their curriculum requirements, whether you're following the NGSS or another set of standards. But this particular device really contributes to a strong knowledge of being able to work with data and interpret it, which is going to be applicable to any career that kids go into and is more than likely applicable to many of the activities you're doing. So now, Paolo asked about drones. Well, that's actually next up right here. And you can see a little picture of a Tello drone there in the upper right-hand corner carrying a databot. And one of the things that comes in your kit, which actually wasn't on that picture, I should have mentioned it, it comes with these Velcro dots, which you can see there on the bottom. Now, the mass of databot is 34 grams, and you put one Tello dot underneath, or one Velcro dot underneath the Tello here in the front, And then the other one is on the databot, which allows you to stick it on there. It's easily added or detached. One of the important things is to make sure you mount it far enough forward so that the sensors in the back are still clear. Otherwise, your drone's going to be a little confused. It's going to think it's sitting on the ground. But anyway, once you do that, you have access to all of the drone or all of the sensors that are on board databot. And that allows you to do different kinds of missions with the Tello. So learning how to fly the Tello and activities like that is fantastic for kids. It's very engaging. But when you go to this next level, you're actually adding in a level of, scientific rigor. You're also introducing a lot of different applications for drones in real life. So some of the missions, for example, that we've actually produced, one of them it's a really fun one. It's called We've Struck Iron. And it's about trying to find iron ore deposits using your drone. So the way we do that, now iron ore, of course, is magnetic. So if you're searching for ore deposits, you'd be using the same thing that is on board databot, a magnetometer. So the challenge is, and we do this by putting magnets under different pads in a field, and you have the kids actually scan that field. So you can do this different ways. One of them is live using Vizeey. So if you're flying inside a classroom and you've got your drones within Bluetooth range, you can fly them in mission duos. So you've got one student who's acting as the data scientist and the other student's the pilot. And of course, the mission of the pilot is to fly the mission as quickly and as efficiently as possible, get over all of those different pad points that you're looking at. And as soon as the pilot gets over that, an initial pad point, for example, the data scientist is going to have to be watching that Vizeey readout and saying, hey, no iron here, move on fast. And, you run the course as quickly as you can, because that was one of the challenges we had. We wanted it to be timed. So get in and out as quickly as you can and identify the correct locations of the ore deposits using the magnetometer. So that's a good example. Now, instead of using Vizeey, if you're using a larger drone and you're working outdoors, another mode for databot is what we call server mode. Now, I had mentioned that depending on the position you turn it on in, like if I turn it on right side up, again, you'll notice it's got a blue light flashing there. Hopefully you can see that in the screen. If I turn my databot on upside down, like so, it's going to come up in what we call server mode, and it'll have a green light flashing. So there are multiple modes that you can turn databot on in. One of them is for coding, for example. Server mode is pretty interesting because it allows you to access databot as an actual web server. So it's actually made itself available to you to connect to. You pull up your browser, and then you use different dashboards that are being served up. One of those dashboards is for these drone missions. And so we've got 4 of them mentioned here. Etch-a-Sketch is one, for example, where you fly your drone over a surface, and it's using the proximity sensor to bounce a signal off the surface. And you actually can map out the altitude of the elevation as you're flying over it. So that's one of the challenges is Etch-a-Sketch, your elevation or the landscape that you just flew over. So another one using the color sensors. Can you identify a difference in, for example, between asphalt, dirt, and grass? So can you fly a mission where you actually identify within different timestamps, when was I over grass, when was I over asphalt? Anyway, the way server mode works, you configure the mission and the sensors that you want recorded. It's going to record those while you fly, and you're going to be out of, let's say you're out of range of Bluetooth. When you bring the drone back, you reconnect to it, you download all that data from the drone or from the databot, excuse me, and then you go into your analysis phase. So it's a great application of, real world career type uses of drones, but also of data analysis, because you're pulling those data sets in and you're saying, okay, here's a challenge. Somewhere within your mission, you flew over an iron plate. Can you tell me where your timestamp was and tell me where you were, do you think, in your mission, just by looking at the data? So server mode's great because it gives you a lot of different dashboards for things like environment, and then also configuring your own unique experiments. We have actually had a number of schools send these up in high altitude weather balloons. So you can set them to record things like, all of your different air quality readings. You can do CO2, humidity, temperature, volatile organic compound levels. Anyway, you can do that also with a drone. You can do an air column experiment where it flies straight up and takes readings, at different levels. So anyway, lots of ways to apply it with drones. And we've got different curriculums being built by different organizations actually to integrate it with drones. So I think we're just getting started with that. Version 1.0 was too heavy to be used with telos, but this version actually is a small enough payload that we're excited to see what's going to be done with it in the classroom. So this screen gives you a quick overview of some of the other platforms that you can use with databot. I had mentioned you can use Excel. There's a plugin that allows you to stream live data right into Excel, which is really interesting because kids can actually have, let's say, 3 columns of data coming in. It's streaming real time. You can highlight those and drag out a line chart in real time, and it'll be charting things like air quality levels right in Excel. So it certainly makes spreadsheets a little bit more fun. Arduino is a software platform that is quite ubiquitous for a lot of STEM and technology teachers. If you're familiar with Arduino, databot is built on the Arduino platform. You'd be able to plug right into it and code it using Arduino. We provide all of the technical details on databot, including the sensor data sheets, the addressing, so that you can do that. It's designed to be hacked and explored and used in a lot of different ways. We have our own physical computing environment as well called Data Blockly, and that's actually one of the modes. You turn it on in a particular mode, button side up, and it's going to flash some lights at you and let you know that it's ready to be programmed. And you can plug into Data Blockly, and then you can start creating programs that interact with the sensors and sound and light. This is just a quick snapshot of an advanced application. So if you're teaching high school and university level, machine learning, of course, is teaching kids about artificial intelligence and how to create machine learning objects that allow your devices to become somewhat smart and solve problems in the absence of data that should be there. For example, they can fill in the blanks. One of those platforms is called TensorFlow. And since databot is built on a platform, it's called the ESP32 is the processor, which for you Uber geeks out there, you'll know what that is. But it allows you to create TensorFlow models and download them to databot and treat it as an edge computing device. That means that you can actually teach it to do something in particular and put it out on a network, and it'll sit there and do whatever it is you've designed to do. So for example, it might be gathering a data set of environmental variables. And let's say something happened that interrupted the flow of data for a certain number of variables. Your machine learning model could fill in those blanks for you and help you understand, okay, this is probably what was going on during that time, even though we weren't able to collect data. So those are some real world advanced applications of using databot. And this is the final slide, I think, before we go on to the end, where Paolo is going to announce the lucky winner of one of these databots. There's an expansion system called Grove, which for those of you who are familiar with Arduino, again, this is an Arduino based system that's out there. So it allows you to purchase really inexpensive sensors that can expand on the capabilities of databot. And I think there's probably over 150 sensors in the Grove system. But they work with Arduino boards, they'll work with databot. We have an adapter cable we've designed that would allow you to connect to any of these external sensors. And there's things like, on the right-hand side, there's a water level sensor. There's soil moisture sensors, where if you're doing, greenhouse experiments and you want to be tracking the temperature and moisture of your terrarium, you could do that. Heart rate sensors, a whole host of specialized gas sensors. So a lot of different things you can do to expand databot with some fairly inexpensive, materials, which is one of the things we're trying to do, is make sensors and data accessible to a wider audience, especially at the elementary and middle school level, for a much lower price point. And I think that's it. One device, many applications. You can use it from grades 4 through 12. You can use it in informal, formal classrooms. You can code it, you can launch it, you can do all kinds of fun stuff with it. So super flexible tool. And with that, I'll pass it back over to you, Paolo.
Definitely. Hey, Robert, thank you very much. I think that it's an innovative product, and we love the components of the basic science concepts and things like that you can look at and incorporate into the teaching environment, but also the data sciences piece, the ability to collect the data, analyze it, and even interpret it. And it's very interesting because it's so small and modular. So thank you very much for doing that. What I do want to do is, I know there was just a question that came up in regards to the raffle, the most important thing. If there's any other questions, feel free to ask while I'm pulling up my slide here. And let me just put it in. Long and short, Robert has agreed to provide a databot 2.0 single kit as a raffle award to some lucky attendee today. And so what we'd ask is you just send an email to Palo, P-A-L-O, at eduporium.com. So it's P-A-L-O at eduporium.com. Just give us your name, title, school, address, phone and email. And the most important part is how you would like to use the databot 2.0 in your environment. And what we'll do is we'll take a look at the people who come back responding, and we'll make a selection in conjunction with Robert, and someone is going to go back with a databot 2.0. So we want to thank you, Robert, for offering that. So let me just stop my share and just see if there's any other additional questions that I may have missed. Let's see, is there any other questions? Oops, sorry.
One thing I forgot to share was just the configurations. So for anybody who's interested in, how it's configured for purchase, you can get it in singles, twin packs, or a class pack, which is our recommended set for the classroom of 10.
Cool. Sorry, I just got too many too many slides going. So I will put this. Let me just put something up in the. Andy, if you could put what my email is, so if anybody forgot what we were talking about. So, are there any other questions by anybody out there? If not, we want to thank you today for attending. I want to thank Robert for attending, and also for his generous offer of the databot 2.0. I think that's great. It's an innovative product, as I've said, but I do want to thank Robert and the team, and thank everybody for attending today. We know it's very busy out there and you've got a lot on your plate. Hopefully the school year's coming to a close quickly here, and you're all safe. But once again, Robert, thank you very much. Let me just see if there's any other questions. Oh, yes, we will share. Anybody who registered, we will be, because of the way Zoom captures your emails and stuff like that. So everybody will get a copy in a day or two, a copy of any slides that Robert put up, any recording copy, or it'll be on the blog, and actually also probably, and most likely, and the winner of the raffle. So I think that's it. Let me just see.
We'll also send over a copy of the Ninja Walk curriculum, so they'll have that full lesson plan that they can try at their class.
Yeah, definitely. And Robert, you at your site, you have tons of other curriculum and things like that, and things to help teachers use the product and stuff like that. I know we've talked about that. Cool. All right. Well, thanks, everybody. Have a great day. Thank you for joining today.
Thanks all. It's great to be here. Thanks. Bye.
Bye-bye.